What is the need of study of mechanics of rigid bodies? So by studying the mechanics of rigid bodies provides the fundamental knowledge which is essential to understand and also to analyze the behavior of solid objects under various forces and also the moments. So by studying both kinematics and dynamics of the rigid bodies, one can control the motion and stability of these objects in practical applications too. So to discuss about all these issues and all these concepts, we have two experts with us in the studio today. Dr. N.V. Prasad Garu, Associate Professor, Department of Physics, Osmania University, Hyderabad, and Dr. TSPLN Prasad Garu, Associate Professor, Department of Physics, AV College, Hyderabad. Dr. N.V. Prasad Garu, so if we know the forces acting on the body, we can understand and we can describe the motion of body. So can you elaborate on this by discussing what is the concept of mass and what is the center of mass and motion, what is the reduced mass, and all those things, can you please explain?
Thank you, madam. Before going to the concept of mass, in Telugu language you call 𝗧𝗦𝗔𝗧 and 𝗂𝗏. Mass is nothing but as 𝗧𝗦𝗔𝗧 and weight is equal to 𝗂𝗏. 𝗧𝗦𝗔𝗧, ద్రవ్యంలో ఉన్న రాశి, the word itself gives exactly the meaning of that. To understand more about the mass, we should recall the kind of Newtonian laws of motions. What he says that based on the inertia, if you can understand mass, it can understood thoroughly. So mass is nothing but as inertia of mass. Inertia of mass, if you put into that, then it will give you more explanation on that. What is inertia of mass? It is nothing but as we apply the law of inertia into that. As long as no external force acting on that, the motion of the system of the body remains same. If you apply some force only, rest can move to the motion, or in a uniform motion it will be like that only. So the inertia mass means mass does not change until unless if you apply into that, it's a constant. Therefore the mass can be understood by means of inertia of mass. So mass is nothing but as inertia of mass. If you put into that, then the gravitation force, what is the gravitation force, is acting on the body is nothing but as a weight. Weight is related to the gravitation force. If you put into the mathematical equation, it comes out W is equal to mg. You call this as equation 1, which is shown in the monitor. So W is equal to mg. So W is nothing but as a weight. Weight is nothing but as gravitation force. If you recollect it, W is equal to mg. So if you recollect it this, then where m is the mass and g is acceleration due to gravity. So this equation can be re-expressed as W by m is equal to g. So what is inertial mass? So weight of the body is directly proportional to mass. So weight of the body is directly proportional to mass. So mass and the gravity, they are related terms of these equations. Now you put into the first law of equations that force, you know that according to Newtonian laws, force proportional to ma. So force can acting on that K into ma. So K is nothing but as a constant or proportionality constant, where m is mass, a is acceleration for one particular body. So F is also proportional to m1a1. So if you call F is equal to K into m1a, where K, the proportionality constant, they are same. So K is there and here also K is there. If you're dividing over here, then what we'll get is m1a1 by ma is equal to 1. From that, what you say that m1 is equal to a by a1. Now coming to that, what is the cause called gravitational mass? So let's say mass is nothing but as inertial mass, and you're putting gravitational mass. So gravitational mass, inertial mass, they are related to each other but not same. So this is given more concept given by principle of equivalence by Albert Einstein, that will come to after that. So now the force, what is acting on that force, which is nothing but as a weight, we call WA, which is equal to G into mu A into mu E by R square. So what is mu A? Mu A is nothing but as the mass of object A, and mu E is mass of earth, because we are putting the all masses in the gravitation fields. Therefore called mu A the mass, and this another mu A earth mass by R square. It is given by Newton's equation that the force acting between the two bodies is nothing but as the product of masses and inversely proportional to square of the distance. So the same law you are putting over here. So Fa is equal to Wa, which is nothing but as G into mu A into mu E by R square. You are talking about this, you are talking about A particle and the attraction between Earth and the particle A on the Earth. Similarly, for particle B, Fb is equal to Wb, which is equal to G into mu B into mu E by R square. Since gravitational inertia masses, I already told you, they are proportional to each other. Therefore, from this equation, we can say what is Ga? Ga is nothing but as Wa by Ma, the earlier equation. So, what is Wa? Wa is nothing but as G mu A by R square, what we are putting here, and by Ma. For what is Ma? What you are getting Ma? This Ma, I am putting our Ma here, and Wa is nothing but as all this term G mu E Ua by R square. From this equation you are putting here. Since the gravitation is same, so we call Ga is equal to Gb. So if you equate to that, so what you are getting is mu A by mu B is equal to Ma by Mb. From that we say that the gravitational mass and inertial mass, they are related to each other, but they are not equal to each other, equal to not each other. Then Telugu language, if you put into that, జడత్వ గురుత్వ ద్రవ్యరాశుల మధ్య ఉన్న అనుపాత ధర్మమే గురుత్వ ద్రవ్యరాశిని సున్నితత్వాలో కొలవడానికి ఆధారం. Since there is a relation between gravitational mass and inertial mass, so one way we can measure the mass by means of simple balance. So that he has given by a kind of statement that జడత్వ గురుత్వ ద్రవ్యరాశుల మధ్య ఉన్న అనుపాత ధర్మమే గురుత్వ ద్రవ్యరాశిని సున్నితత్వాలో కొలవడానికి ఆధారం అవుతుంది. ఈ గురుత్వ జడత్వ స్వభావానికి ప్రతిరూపమని Einstein has given. Einstein said that the nature, whatever you say, that they are not separable. I mean, gravitational mass and inertial mass almost are related to each other, which gives about principle of equivalence. So this principle of equivalence explains about further. Still, the research is going on into this. Now coming to the center of mass, what is exactly center of mass? Center of mass tells about if you have two masses are there, then in order to explain about that, center of mass we required about that. For example, in stellar objects, this moon is rotating like that, assume that, and Earth is that, then there what is the center of mass lies on that here, plus is the center of mass of the system. So see, the center of mass of the system is like that. Good example of the center of mass, if you look into that, this is exactly the center of mass of the system. So center of mass of system may not be inside. For example, halo ring, the center of mass exists outside of the ring. This is an eagle, you say eagle force, then there is a peak, this is called a peak. That's called peak. Then the center of mass also here is there. So if body is not uniformly distributed, then the center of mass lie outside of that. If body is uniformly distributed, then the center of mass lie inside of that. This is halo kind of things. So the center of mass is exactly at peak of that. If you put into that, this is all halo mass. So if it's solid mass, the center of mass is entirely different. Like ring is there, halo ring, the center of mass will be away from the ring. So to understand about center of mass, we require the coordinates. So x center of mass and y center of mass. So x center of mass can be represented by m1 x1 plus m2 x2 by m1 plus m2. Means that when you have two particle system m1 m2, and let us say the origin, the distance from origin to the mass where it's situated called x1, that from the origin the distance what is situated mass m2 is x2, the next center of mass can be represented by product of m1 x1 plus m2 x2 by m1 plus 2 m2. So center of mass in Telugu they call 𝗹𝗫𝗁 𝗃𝗃. Similarly, y center of mass also can be defined by m1 y1 plus m2 y2 by m1 plus m2, where y1 y2 are nothing but as coordinates of y center of mass. So x center of mass can be represented by m1 x1 plus m2 x1. If number of particles are more, then you call m1 x1 plus m2 x2, so on up to that, divided by m1 plus m2. So in mathematical language, we said that summation or I mi xi divided by summation or mi. Summation of mi is nothing but the total mass of the system. Similarly, y center of mass can be represented by summation or mi yi by mi. Similarly, z center of mass, you have other coordinate z center of mass, then this can be explained by my zi by summation or my. In Cartesian coordinates, if you want to write the r center of mass, the Cartesian coordinate write the x center of mass, y center of mass, z center of mass. So this can be represented by all this thing ix, jy, kz by mi, where I, j are nothing but as unit vectors and xi, yi, zi are the coordinates situated in three-dimensional concept. So in brief, you said that which is equal to summation or mi ri by mi. So the summation mi is nothing but as total mass of the system. So total mass of the system into r center of mass is equal to mi into ri. So the same equation if you put into that, so m r center of mass is equal to summation of mi Ri, then if you differentiate it, so when you differentiate is what happens, m into drcm by dt. So drcm by dt is nothing but as vcm. So m into vcm is equal to mi into Ri. Ri means dri by dt. You are differentiating both sides. So dri by dt can be represented by vi. So similarly, if you differentiate once again here, so what happens, m into dvcm by dt is nothing but as acm, and dvi by dt is equal to ai. So ma center of mass is equal to mi into ai. So to understand about the m center of mass, so mass, total mass of the system, acceleration of the center of mass is nothing but as summation or Fie plus Fij. What is that? This is nothing but as interaction of the two body particles and body-body interaction of the particles. The body-body interaction of the particles cancel to each other. Therefore, we can neglect this. So Fij is nothing but as equal to minus of Fji. Fij is equal to minus of Fji. Therefore, we can neglect this term. So if you neglect this term, F bar is equal to simply summation or Fi, which is nothing but as S. So Ma center of mass is nothing but as axial force acting on the system. So MaCm is equals to Fe. For example, this is a good example of that. Two binary stars which are rotating on that. The center of mass over here is that. So the binary center of mass. So the gravitation depends on this, and this gravitation depends on that. So therefore, the center of mass lies over here outside of that thing, and because they depend on this two gravitation depends on that. So this is a good example of the binary star experiment. Now, if you want to understand further the center of mass of system, we go to the one problem. Based on the problem, we can understand more about that thing. For example, let us say 4 kg mass is situated here at 1 meter away from the origin, and 2 kilograms of mass is situated about 4 meters away from the origin. Let us say, then you take a positive x-axis called positive distance, and this negative x-axis called negative distance. Then what is the center of mass of the system? How to calculate about that? And what is the velocity of center of mass? So what is the problem says that 4 కిలోలు 2 కిలోల ద్రవ్యరాశి గల వియుక్త కణాలు 4 మీటర్ per second 2 meters per second వేగాలతో గమనానికి లోనవుతున్నాయి. So they are moving at the velocity is 4 meter per second and 2 meter per second of 4 kg mass and 2 kg mass. At any particular time, they are like this. They are like this means the 2 kg mass at a particular time they are apart from 4 meters, and at a particular time the 4 kg mass apart from is called 1 meter on negative axis. Then what is the, how to find out the velocity after 10 seconds? So what is the velocity of that you have to find out. So in order to calculate about that, so what is x center of mass? X center of mass formula is summation or mj xj by mi. So here now x m1 into x1 plus m2 into x2. So m1 is nothing but as 2 kg into x1 is equal to 4, you call, because positive axis is a 4, so you're putting 4 here. Then m1 is equal to 4, m2 is equal to 4, sorry, and the distance is equal to -1. You said that -1, so you put -1, and the total of mass is nothing but as 2 kgs plus 4 kg you are putting here. So if you calculate it, get 2 by 3. Similarly, what is VCM? VCM is nothing but as summation of mj vj by mj. So mj means mass into what is the velocity? Velocity is nothing but as here now 2 meter per second you putting here, and m1 v1 plus m2 into v2. So here m1 into v1, so the direction is opposite direction of that, therefore 2 kgs into -2, and m1 it is going this direction, so you put +4. So 2 into -2, 4 into 2, if you calculate it, you get 2 meter per second. Then how to calculate the position after 10 seconds? So the uncertainty position can be represented by velocity divided by uncertainty time. So delta x is equal to VCM into delta t. So based on this equation, so what is VCM? VCM you calculated that 2 meter per second, so put here 2 meter second, and what is uncertainty dilation of time? Delta t, you put 10 seconds. So if you calculate it, it will come out 20 meters. Therefore, the position can be represented by V center of mass is equal to V center plus delta x. So what is that? V 2 by 3 is xm. So xcm plus delta x. xcm plus delta x, if you add together, you will get 20.66. So that means that V center of mass is apart from 20 point that thing after 10 seconds. Earlier it is what? Somewhere the distance, now they move 20.66. For example, center of mass of a rigid body, if you want to calculate that. So rigid body means many masses are there. So the fundamental definition, when mass tends to infinity, so when you call rigid body coming to that, so mass, the mass when divided into subatomic masses, if subatomic masses are infinite, then you put into the center of mass of a rigid body. So x center of mass is equal to delta mi xi by delta mi. Similarly, ycm and zcm. So in limit calculation, if you put it that, so delta x, delta mi with a very small delta m tending to 0. So by definition you can say this integral delta x dm by integral delta m. So if it is nothing but as m, so you can say 1 by m integral x into dm. If you look into this equation, integral x into dm, and integral dm is nothing but a summation of masses, which is nothing but as m. Similarly, y center of mass, similarly z center of mass. So in general, the equation can be described by r center of mass is equal to 1 by m integral r into dm. This is a general representation of given by r center of mass. For symmetric, symmetric objects, the center of mass lies on that. Center of mass lie at a point or a plane or on a line. This is what center of mass definition goes. So this is, if you put planes, there's a center of mass here, circle, center, here, like that. See, the boy is throwing a object, the center of mass is the dots, so the center of mass, the path of the center of mass is nothing but as parabola. All the center of mass lie on the parabola. This is the path of the center of mass. If a boy throws a stone or a kind of object, then the center of mass goes like this. Then coming to the reduced mass. Reduced mass, they have given in Telugu word called 𝗂𝗽𝗱𝗁𝗺. So how can you understand the reduced mass of the concept? For example, this is a two-body system. What figure has shown this two-body system? This is a one-body system. So let us say mass m1 is there, then mass m2 is there. The force acting on this direction, positive, and the force acting in this called minus F. And then you have a spring attached to between two masses, and the spring constant called K. Here, the force acting on minus F, mu. Reduced mass generally will come when mass is very less, when two bodies are there. Then you put reduced mass. So this you call one body body. So we have only one body having a spin constant K, but the force acting on that thing. So to understand about that, let us say the distance x1 from the origin is equal to, for m1, and the distance origin is called x1. And from m2 and the origin, the distance called x2, let us say. Then spring constant is equal to k. Then here, the distance for one body system, what you reduce mass, this is called x. So from the two body system, how can you come to the reduced body? We'll look into the simple example. So since you said that this is spring, so it obeys harmonic oscillator. So harmonic oscillator formula you can apply it. So m1 into d square x is equal to d square x by dt square is equal to kx, where x1 is nothing but as displacement here. This x1 what you are putting. So the force acting on the system m1 into d square x by dt square nothing but as acceleration, which is equal to minus kx. F is equal to minus kx, nothing but as Hooke's law. So m1 into d square x1 by dt square is equal to minus kx. Similarly, for x2 particle, m2 is equal to d square x2 by dt square. Since the force is in this direction minus f, so you put plus x. m1 m2 is equal to m, then what happens? Mu is equal to 1 by m2. Before going to this equation, now this equation we put it, you multiply with m2 the above equation, this equation m1 on both sides and subtracting. So the above equation you are multiplying with m2 on both sides, and the below equation you are multiplying with m1 on both sides and subtracting these two equations. Then what you get is, you get this kind of equations, and rearranging this equation will get m1 m2 by m1 m by m2, and this equation d square by dt square x2 minus x1 like this. So this m1 m2 by m1 plus x2 nothing but as a reduced mass, you call mu. So then this is called d square by dt square is equal to, you come over here, this becomes mu. Then it is minus kx, so what is that? This comes over here plus. So k by mu, that nothing but as d square by dt square, x2 minus x1 is equal to x if you call. So d square by dt square is equal to minus k by mu to x, or d square x by dt square is equal to plus k mu by x. So this is called reduced mass concept of equations. So what is reduced mass? Reduced mass is lesser than the mass what you have two masses acting in the system. So m1 m2 by m1 plus m2. What is the thumb rule? That the reduced mass always lesser than the mass what we have m1 m2. So like that you can understand about that, madam.
Yeah, okay, thank you, sir. Sir, we have heard about the concept of mass, center of mass and motion, and also about the reduced mass. I'll ask a question to T.S. Prasad Garu. Please explain how the nature of the forces responsible for the rotation of the bodies.
Thank you, madam. So in the rotational dynamics, we will discuss about the nature of forces responsible for the rotation of bodies. So how the body rotates. So there is an analogy between the translational kinematics and as well as the rotational kinematics. In translational, linear acceleration is associated with the force, whereas in rotational motion, torque is analogous to the force. So here by applying a force, so we will take an example. So by applying a force to the hinge line of the door does not result in the angular acceleration, whereas if you apply perpendicular to the plane of door, then the outer edge, that is at the edge, it causes the maximum angular acceleration. So with this example you can see the difference between the general force and this type of angular acceleration. So here you see the picture in the 1B and 1A. So in 1B the force is acting on the nut causes to rotate the nut, and the nut tended to rotate by the force as well as the length of the lever arm. And if the force is perpendicular to the lever and in the B section, so here on that one it is a perpendicular motion, then it causes a twist. Otherwise, if it is component simply pulls the nut out of the plane, so it won't use for a rotating in a nut. So similarly, consider this type of a force perpendicular to the this point at P, and R is the so there is a position vector. So from this position vector, so it is a point P, and here it is the total the torque acting on a particle we can define into tau is equal to R cross F. So this R cross F has a dimensional formula or a 𝗧 formula antam ML2 and T2, and దీనికి యూనిట్స్ వచ్చి Newton per meter, and this torque is a vector quantity, and vector quantity then you have a magnitude tau is given by RF sin theta, and here the direction of the torque is normal to the plane, and that is tau is equal to RF sin theta. So this you see how it is rotating, and for this the sense by the right hand thumb rule, you can see that one, that is the arms, how the thumb is up, that is usually through the arrow is given in this one. So this is extended thumb gives the direction of torque, and this tau again we can rewrite, use these equations, the R perpendicular sin theta, F is equal to FR perpendicular, and then we will move on to the angular moment of a particle. Before that, just see how it is. If you are rotating in the perpendicular direction to the plane, then only you can rotate the nut, otherwise it will come out of the plane. So this is a small animation, you can watch and you can observe how the torque is applying on the nut in the CW, that is the clockwise direction. So then we will move on to the angular momentum of a particle. So that angular momentum is rotational motion's equivalent of linear momentum. So define an angular momentum. We will consider a particle of mass m and linear momentum p, and at a position r in the plane given in the figure, and O is that is the origin O, and here we are considering an inertial reference frame, how we are showing in this one. So that angular momentum L of a particle with respect to the origin is defined by L is equal to r cross p, or L is equal to rp sin theta. So that is the momentum vector, and that simply you know what is the p. P is equal to mv, and we can rewrite that equation, and that v is equal to r omega. So here we are getting the L is equal to mr square omega. So this quantity mr square is it plays an important role. This is nothing but a inertial mass, and the quantity mr square is called the moment of inertia, and this mr square is important for revolving masses. So we will take one example for explain the torque and moment of inertia, and you consider two wheels. So the difference between the two wheels is, in the first A figure, the total mass is distributed over the total axis of closer to the axis of rotation, whereas in the figure B, there is a mass is concentrated around the rim. So here so out of these two, in the figure B has more moment of inertia. So this indicates the rotational inertia depends not only on the mass but also on the average distance of the mass from the rotating axis. So if the rotating from the mass is concentrated away from the rotating mass, then the moment of inertia will be more. So the rotational inertia of mass increases as it moves away from the axis. So with that we can use this, and the force of acting on the particle is given by F is equal to dp bar by dt, and the taking the vector product here on the both sides, r cross F is equal to r cross dp by dt, and r cross F is equal to r cross dp by dt, and r cross F is nothing but the torque. So then tau is equal to r cross dp by dt. So then we will differentiate this, the equation, and we will with the reference to time. Then dl by dt is equal to d by dt of r cross p, and that gives r cross dp by dt plus dr by dt cross p. So then since dr by dt is equal to v bar and p is equal to mv, and we can rewrite the equation as dl by dt is equal to r cross dp by dt. So from this we can say this dl, that tau is equal to dl by dt. So this equation indicates the time rate of change of angular momentum of a particle is equal to the torque acting on it. So this is regarding the, we will move on to the angular momentum of system of particles. So far we discussed about the single one. Here we are discussing about the angular momentum of a system of particles. In a rigid body, if the number of particles are more, then how to deal with the angular momentum. So for this consider a system consisting of small many particles. the many particles, you have L1, L2, L3, L4 are the angular momentum of the individual particles. So the total we will add up, and that is equal to L is equal to L1 plus L2 plus L3 plus so on Ln. So L is equal to that total tau is equal to this summation and the total momentum of the system about the fixed reference point. So we are taking about a fixed reference point, and the tau is the resultant external torque. So the change dl by dt arises from two sources. One is torque exerted by the particles of system by internal forces, another with the external forces. So here that the second one, the torque only external force is the responsible for that, and the first one is equal to 0. So the importance of this is here. So that from out of this we can say the total tau is equal to dl by dt. Tau is equal to dl by dt, and tau that we can express this the tau e, that is the external torque, and rate of change of total angular momentum of a system of particles is about the origin of an inertial reference frame and is equal to the sum of the torques acting on the system. So then we will move on to the kinetic energy of rotation. So in the kinetic energy of rotation, here consider the body may be consisting of large number of particles of masses m1, m2, m3, m4, m5.
సార్ ఒక్క నిమిషం సార్. హలో హలో
హలో మేడం.
ఎవరు మాట్లాడుతున్నారండి? మీ పేరు చెప్తారా?
గుడ్ ఆఫ్టర్నూన్ మేడం. సెన్సర్ హియర్.
ఏ ఊరు నుంచి మాట్లాడుతున్నారు?
మేడం.
ఎక్కడి నుంచి మాట్లాడుతున్నారమ్మా? ఏ స్టడీ సెంటర్ నుంచి మాట్లాడుతున్నారు?
Actually, I am an MSc student calling from Hyderabad.
ఓకే, చెప్పండి. మీకున్న డౌట్ ఏంటో అడగండి.
Madam, can you please tell me an example of a rigid body in dynamics?
అచ్చా, ఓకే అమ్మా. సో వాట్ ఈస్ ద రిజిడ్ బాడీ ఇన్ డైనమిక్స్?
The word rigid body means that whatever the distance should not change with time. They call rigid body. In dynamics means in motion. Motion won't change anything, right? And a gravitational force won't change. If body is changing, we know what called rigid body.
కట్ అయిపోయింది.
కట్ అయిపోయింది సార్. మళ్ళీ ఇంకొక క్వశ్చన్ వస్తూ ఉంది. హలో
హలో, మేడం.
అవునండి, చెప్పండి.
అది ఒక మెసేజ్ వచ్చింది, థర్స్డే 2 to 3 లైవ్ సెషన్ ఉంటుంది అని.
సార్ మళ్ళీ కాల్ కట్ అయిపోయింది సార్. సో మనకి ఫస్ట్ వచ్చిన క్వశ్చన్ ఏంటంటే వాట్ ఈజ్ రిజిడ్ బాడీ అని అడుగుతున్నారు.
What is the basic definition?
Yeah.
of that? And dynamics won't
Under
change.
any kind of forces, it
won't change
it won't change anything. Yes. Yeah, you can continue, sir.
Okay. So here we will continue about the kinetic energy of rotation of momentum. So that K1, what is that K1? K1 is equal to half m1 vi, and using that G is equal to R omega, and from that K is equal to half mi Ri square omega square. So from this the total kinetic energy we will calculate the individual particles how they are moving according to the moment of inertia in the rotation. So here that total kinetic energy K is equal to finally half I omega square. So this I omega square we will arrive at this final for I omega square, and if I is equal to mi square Ri square, and moment of inertia if you calculate r is equal to 1 by m to the power whole square. So thus radiation of gyration of r of a body is square root of the ratio of moment of inertia of the body to the mass of the body. So there is a I by m ratio and under root. So this is moment of inertia is very useful in calculating the other how it rotates or how it moves as a rigid body. So here we have some examples using this is a loop about cylinder axis, and here I is equal to moment of inertia is equal to mr square, and here if it is a rod of a thin rod and it is rotating about its axis perpendicular to its length, then it moment of inertia is equal to ml square, L where L is the length divided by 12, and if it is a solid sphere it is 2 by m r square, and similarly if it is a disc of a thickness small it is equal to half mr square. So that we will discuss, and here this one is a moment of inertia of a wheel. So this is nothing but a type of a wheel. So here in this moment of inertia we will calculate the total mass by taking a small delta m here in the ring as a about radius distance from r, and I is equal to r square summation delta m, that is equal to r square m square. And if the moment of inertia, here we observed this is axis of rotation is through the perpendicular length at the center, but here
sir oka nimisham sir. Hello, hello, hello,
హలో
చెప్పండి, ఎవరు మాట్లాడుతున్నారు?
హలో మేడం, నేను బిఎస్సి ఫస్ట్ ఇయర్ మెకానిక్స్ మీకు ఇప్పుడు లైవ్ లో వస్తుంది మేడం.
ఓకే మా,
డౌట్ విత్ ప్రసాద్ సార్ మేడం.
చెప్పండి, మీకు డౌట్ ఏంటి?
సార్ could you tell me and then general example of this rigid body in dynamics, sir?
General example of?
Yeah, sir. Yeah, ma'am.
Can you please repeat the question?
Yeah. Could you tell me an example of a rigid body in dynamics?
Yeah, okay, fine. ప్రసాద్ గారు, మీకు
ఇక్కడ మనకి ఎదురుగా కనపడుతుంది దాంట్లో పీపీటీలో
ఒకసారి మీరు స్క్రీన్ చూడండి, మీకు తెలుస్తుంది, మీకు ఎగ్జాంపుల్ చూపిస్తారు.
ఉన్నది ఈ వీల్ ఎట్లా మాస్ ఎట్లా ఇక్కడ కాన్సన్ట్రేషన్ ఎడ్జ్ లో కాన్సన్ట్రేట్ అయినప్పుడు అది ఎట్లా మూవ్ అవుతుంది. ఇట్ ఈస్ ఆల్సో ఎగ్జాంపుల్ ఫర్ రిజిడ్ బాడీ. అండ్ ఈవెన్ దిస్ మీరు యూజ్ చేసుకుంటే దీన్ని ఇప్పుడు మన జైంట్ వీల్ కానీ ఇట్లాంటి వాటిలన్నిట్లో కూడా ఇది ఏ టైప్ ఆఫ్ దట్ టైప్ ఆఫ్ వీల్, మొత్తం మాస్ అంతా ఎడ్జ్లో ఉంటుంది. సో ఇట్ ఈస్ వన్ ఎగ్జాంపుల్ ఫర్ రిజిడ్ బాడీ.
ఓకే, యా, యూ కెన్ కంటిన్యూ యువర్ డిస్కషన్ సార్.
So like this we can calculate that moment of inertia of a different shaped bodies if this body is fixed at the edge of a length L, that is O. So this is axis perpendicular to its length and it is rotating in a counterclockwise or a clockwise direction. So how do you calculate the moment of inertia for this body? So that is, you can calculate moment of inertia I is equal to mu dx by x square, and ultimately the total this type of a rod you will get I is equal to ml square by 3. Where mu already మీకు తెలిసిన విషయాలు మ్యూని ఎల్ అనేది లెంగ్త్ ఆఫ్ ద రాడ్ అండ్ m is the mass of the rod and I is the moment of inertia. And a rigid body, if it is suspended at the center of the rod, and this is equally, the total length is divided by x by 2 and x by 2, or if it is a total length is x. So from this you can calculate the total moment of inertia, and that I is equal to ml square by 12 if it is a rod is suspended at the center of the mass. And similarly, moment of inertia of an annular cylinder. This annular cylinder is nothing but two concentric cylinders are inserted in the same cylinder. So for this, that means దీంట్లో మీరు తెలుగులో ఉన్నది గుల్ల అంటే లోపలంతా హ్యాలోగా ఉన్న ఒక లోహ వస్తువు. సో దీనికి మొమెంట్ ఆఫ్ ఇనర్షియా టోటల్ వచ్చేటప్పటికి I is equal to R2 square plus R1 square into half m. సో ఈ విధంగా మీరు అన్ని వేరే వేరే వస్తువుల వాటికి మొమెంట్ ఆఫ్ ఇనర్షియా విత్ డిఫరెంట్ ఎగ్జాంపుల్స్తో మీరు కనుక్కోవచ్చు. ఆ మొమెంట్ ఆఫ్ ఇనర్షియా అనేది ఎందుకు ఉపయోగం అంటే హౌ ఇట్ రొటేట్స్ ఆర్ హౌ ఇట్ మూవ్స్. సో ద టోటల్ I is we calculated using mr square. ఇదే విధంగా చాలా ఎగ్జాంపుల్స్ ఉన్నాయి, వాటిలన్నిటికీ కూడా మనం క్యాలిక్యులేట్ చేయొచ్చు మొమెంట్ ఆఫ్ ఇనర్షియా. మొమెంట్ ఆఫ్ ఇనర్షియా క్యాలిక్యులేట్ చేసి మొమెంట్ ఆఫ్ ఇనర్షియా ఎక్కువ ఉంటే ఏమవుతుంది, తక్కువ ఉంటే ఏమవుతుంది అనేది మనం డే టు డే లైఫ్లో కొన్ని ఎగ్జాంపుల్స్ ఇచ్చి చివరికి మళ్ళీ ఒకసారి చూద్దాం. ఇప్పుడు
So far we have heard about the torque and angular momentum and energy and moment of inertia. N.V. Prasad garu, please explain if the axis of rotation coincides with the axis of symmetry, what happens to the moment of inertia of that body? If the axis of the rotation does not coincide with the axis of the symmetry also, what happens to that body? And we know there are two theorems to explain these things. There is the parallel axis theorem and perpendicular axis theorem. Please explain.
Madam, moment of inertia, what now sir said that moment of inertia is I is equal to mr square by 2. He has given the explanation. So in order to calculate the moment of inertia, for example, if the symmetry axis and the rotations are the same line, you can easily calculate the moment of inertia of any body. If the rotation and the plane of the symmetry, what is symmetry axis, they not coincide to each other, then it is very difficult to calculate about that. In order to calculate that kind of things, we adopt two theorems like that. So one called parallel axis theorem and is called perpendicular axis theorem. So parallel axis theorem means the word is called parallel. So we have a plane kind of things. The moment of inertia of any axis we want to calculate, the moment of inertia about that plus m into the distance of that. So that you call parallel axis theorem. When you say perpendicular axis theorem, it is like this. So if you know moment of inertia about this and moment of inertia of that, so this moment of inertia plus this moment of inertia is equal to moment of inertia from Iz. So let us see how they calculate about that into that. So parallel axis theorem nemo samantara సిద్ధాంతం అని, సమాంతర అక్షాల సిద్ధాంతం అని, పర్పెండిక్యులర్ అంటే లంబ అక్ష సిద్ధాంతం అని కనుక్కుంటారు. సో parallel axis theorem, if you want to prove, we have little bit mathematical equations are there. So let us say this is all rigid body whatever we have, then this is called y-axis, they call z-axis and x-axis. Then we want to calculate the moment of inertia along the z-axis. How to calculate that? So I is equal to moment of inertia is nothing but as mr square. So r square is nothing but as xi plus yi. What are xi yi? Let us say in a rigid body we have a point P where coordinates are xi yi. Then the point is situated is m. The mass is nothing but as m. So mi, what you call mi. This is center of mass of the system. So the center of mass and the mass which is situated here at P, the distance is depart by ri bar. Then the center of mass to the origin, what you call r0. And similarly this is called r1. So if you put that kind of notations, then I is equal to m into r square. So mi means all the mass what you have m, and r square means nothing but as coordinates of xi like that. So xi can be represented by x center of mass distance plus xi prime. So similarly if you say xi can be represented by x center of mass xi prime. What does it mean? The center of mass and P are not the same, they are apart from each other. example, the distance over here it is equal to C and P are not same points. So if you say xi in terms of center of mass plus the extra point is yi in terms of y center of mass distance and apart distance. So if you put like that, then what happens, simply a plus b whole square formula you apply it. So x square plus a square plus b square plus this 2ab. Similarly y is a square plus this is b square plus 2ab. Square is wrongly has written, so please delete this 2. Then I is equal to, so since sum is there, so summation of x square yc square you are putting here. Now mi ri prime square, the extra distance is what you are putting here, and these two things are there. So this equation can be represented by I is equal to m into this whole center of mass of this plus the extra distance is what you are putting here, and this is same as what you are putting over here now, right? Now coming to the next further, RC is equal to L. What is RC? The distance between here to here is equal to, you have L distance is there. That means you have the axis over here and you have axis over here. The distance between the two axes is nothing but as L. So you are putting here now L square. So RC is equal to L square, nothing but as that. So since MI bar is equal to 0, so this and this will cancel out. So there is no, we become 0, these two parts. So now totally what you are getting, I is equal to IC plus ML square. This is what you say parallel axis theorem. So center of mass of the system is nothing but as moment of inertia about the, moment of inertia to calculate is, so moment of inertia about the center of mass plus total mass of the system and the distance between the two axes. This is very important, that is L square. So this says about the parallel axis theorem. So in physics language you put into the words, here is there, the moment of inertia of a body about an axis parallel to the given axis and passing through the center of mass of the body and the product of total mass of the body and square of the distance. So moment of inertia you want to calculate, the moment of inertia for the parallel is equal to the moment of inertia of center of mass of the body plus total mass of the body plus the distance between these two things, you are putting L square. So this is called parallel axis theorem. Parallel axis theorem you can apply anywhere, but perpendicular axis theorem is you can apply only two-dimensional concept only. For example, if you want to three-dimensional, then the parallel concept you put laminate kind of things, then you sum up, you get perpendicular axis theorem. Look into the perpendicular axis theorem. So let us say this is, we want to calculate Iz, then this mutually perpendicular is very important that. So Ix, Iy, they are mutually perpendicular to each other. Then the moment of inertia is equal to the moment of inertia about this axis plus the moment of inertia about this axis. So Iz is equal to the moment of inertia is equal to mi r square, where r is equal to x square y square, because already told you these are the coordinates. So Iz is equal to summation or mi, then r square you substitute over here, you get these equations. So totally Iz is equal to Ix plus Iy. If you have a rule like that, the moment of inertia is equal to moment of inertia plus moment of inertia, but the moment of inertia should be a point of intersection of this point of intersection, then the moment of inertia is equal to this plus this is equal to moment of inertia. This is a parallel axis, perpendicular axis theorem states that. So I already told you parallel axis theorem you can apply anywhere, but perpendicular axis theorem has limitations, so it apply only two-dimensional. When you put three-dimensional kind of concept here, then you have to divide into lambda kind of things. Some of all these sheets, planar sheets, will give you the cylindrical format. So this is a two-dimensional concept. So if you put all two-dimensionals, you get three-dimensional.
Phone call. Hello. Hello. ఓకే కట్ అయిపోయినట్లుంది సార్. హలో,
నమస్తే మేడం.
నమస్తే అమ్మా, చెప్పండి, ఎవరు మాట్లాడుతున్నారు?
నేను లావణ్య మేడం, పర్వతాపూర్ నుంచి మాట్లాడుతున్నాను.
చెప్పండి, మీకున్న అనుమానం ఏంటి, డౌట్స్ ఏంటి?
ఈ మెకానిక్స్ లో ఒక చిన్న డౌట్ మేడం.
చెప్పండి.
వాట్ ఈజ్ అన్ ఎగ్జాంపుల్ ఆఫ్ మెకానిక్స్ ఆఫ్ రిజిడ్ బాడీ?
వాట్ ఈస్ ద ఎగ్జాంపుల్ ఆఫ్ ద మెకానిక్స్ ఆఫ్ ద రిజిడ్ బాడీ? అంటే యాక్చువల్లీ మనం 2-3 సార్లు ఇదే డిస్కస్ చేసాము. ప్లీజ్ ఎక్స్ప్లెయిన్ సార్, ప్లీజ్ టెల్ us once again.
I think it is a teacher's question, madam. It's not a student question. Sorry to say that. Some teacher is asking about this question because student will not ask this kind of questions. Okay. So said that since you are asking a question you have to answer that. So mechanics of rigid body. See, and I already told you rigid body is nothing but as the points should not change about that. So if you want to calculate what is the mechanics of a rigid body, so whatever the dynamics what you are talking about, that whatever the kinematics what you want to put about the rigid body to understand the whatever that. So center of mass of the system exactly explains about the mechanics of a rigid body. In other words, I can put into that.
Yeah. Okay, thank you. One more. Hello. Hello.
హలో
చెప్పండి, ఎవరు మాట్లాడుతున్నారమ్మా?
మేడం, నేను హైదరాబాద్ స్టడీ సెంటర్ నుంచి మాట్లాడుతున్నాను మేడం.
చెప్పండి.
రమ్య మేడం నా పేరు.
ఓకే అమ్మా, మీ డౌట్ ఏంటో అడగండి.
మేడం, ఇది లైవ్ ప్రోగ్రామ్ లో సార్ వాళ్ళు ద్రవ్యరాశి కేంద్రాల గురించి చెప్తున్నారు కదా మేడం. సౌష్ఠవ వస్తువుల మీద ద్రవ్యరాశి కేంద్రం అనేది ఒక చిన్న ఎగ్జాంపుల్ చెప్తారా మేడం?
Symmetric bodies, center of mass lies on the planes of the point or the line. So I have given the ఒక్కసారి మీరు దాన్ని చూడండి. These all symmetric bodies only.
ఒక్కసారి మీరు డయాగ్రామ్స్ చూస్తే మీకు అర్థమవుతుంది, దాన్ని ఎక్స్ప్లెయిన్ చేస్తారు సార్.
అక్కడ ఉందమ్మా, this all. This is a center of mass.
ఒకసారి పీపీటీ చూడండి, మీకు అర్థమవుతుంది.
This center of mass which lies on the plane or that thing, intersection of that. Intersection of that కనిపిస్తుంది.
సౌష్ఠవ వస్తువుల మీద ద్రవ్యరాశి యొక్క కేంద్రం గురించి వాళ్ళు మాట్లాడుతున్నారు.
He has given మేడం, చూడండి ఒకసారి మీరు బొమ్మ చూడండి, క్లియర్ గా ఉంది.
Yeah.
Symmetric bodies. Saushtava and symmetric bodies. Symmetric bodies, what these are the center of masses.
Okay.
So they lie on the line or the axis or the point of the whatever called intersection.
Yeah. Okay, so you please continue with the discussion now.
Now this is what parallel axis theorem and perpendicular axis theorem says about that, madam.
Okay. Sir, T.S. Prasad garu, you talked about the torque and angular momentum. You please explain about the torque and angular acceleration also.
So the relation between this. సో మొత్తం మన ఈ 5 నిమిషాల్లో ఇంతవరకు జరిగిన వాటిని ఒక్కసారి అవగాహన చేసుకోవడానికి ప్రయత్నం చేద్దాం. దీంట్లో డిస్కషన్లో మనం ఇంతవరకు వీ ట్రై టు డిఫైన్ ద వాట్ ఈస్ ఏ మాస్ అండ్ వాట్ ఈస్ ఏ సెంటర్ ఆఫ్ మాస్.
వాటిని క్లోజ్ చేసే ముందరగా యాంగులర్ యాక్సిలరేషన్ గురించి కూడా మీరు ఒకసారి చెప్పేస్తే ఒక 2 నిమిషాలు తర్వాత మనము వైండ్ అప్ చేసుకోవచ్చు సార్.
సో హియర్ so in this angular acceleration L
ఒక్క నిమిషం సార్. హలో హలో
హలో
చెప్పండి.
గుడ్ ఆఫ్టర్నూన్ మేడం, దిస్ ఇస్ శ్రీనివాసరావు, డాక్టర్ శ్రీనివాసరావు మేడం.
గుడ్ ఆఫ్టర్నూన్ అండి, అడగండి మీ క్వశ్చన్ ఏంటి?
దిస్ ఇస్ రిలేటెడ్ టు ది ప్రాక్టికల్ అప్లికేషన్ మేడం.
యా.
హౌ డు అడ్వాన్స్మెంట్స్ ఇన్ కంప్యూటేషనల్ అండ్ సాఫ్ట్వేర్ impact the study and application of rigid body mechanics in modern engineering?
So in modern engineering, how do you apply this rigid body of mechanics?
Very fundamental is going on, sir. Actually, for example, center of mass and center of gravity. For example, you want to bring a beautiful aircraft. Where exactly center of mass lie? Where it exactly the that's very important for cars, for fighter jet planes. So because they don't want to tumble down like that. For example, helicopter, it goes completely like that. So it is really having a very good applications in where you want to land in a moon or land to moon that. So the number of applications are there, and people are really doing about that. Center of mass system, how it acts. So that only tells about the technology of the country. The center of mass, where exactly situated, where you can have tilt and other things, and people are really doing, especially jet planes and helicopters and the sports cars. So they have lot number of applications are there to calculate the center of mass, because they are very important, because they want to put perfectly, they want to land. So in such cases they should not have any kind of what you call అంటే మనం సరిగ్గా ల్యాండ్ కావాలి. అలా కాకుండా ఇలా ల్యాండ్ అవుతే మనకి ముఖ్యంగా ప్లానటరీ మోషన్స్లో we want to land in moon, you want to land in another planetary, where you have plan should be perfectly, you should plan about that. In such cases it is really doing about that. Sir,
ఓకే సార్, థ్యాంక్ యూ. ప్లీజ్ కంటిన్యూ.
వీటిలో ఇప్పుడు మనం ఒక్కసారి ఫైనల్గా ఈ గైరోస్కోప్కి దాదాపు దగ్గరగా ఉన్న ఈ రొటేటింగ్ టాప్ కూడా ఈ రిజిడ్ బాడీ వాటికి ఒక ఎగ్జాంపుల్. దీన్ని మనం ఒకసారి చూపిద్దాం. సో ఈ గైరోస్కోప్ అనేది మనకి విమానాల్లో నావిగేషన్కి అన్నిటికీ కూడా ఎంతో ఉపయోగంగా ఉంటుంది. ఈ దీంట్లో ఉన్న 3 ప్లేన్స్ ఇవి ఎట్లా సమాంతరంగా తిరుగుతున్నాయో దాన్ని బట్టి మన నావిగేషన్లో ఈ గైరోస్కోప్ అనేది చాలా ఉపయోగమైనది. సో
జస్ట్ వీ హ్యావ్ వెరీ లెస్ టైం. ఒక్కసారి చూపించేస్తే కనుక
ఇది పూర్తిగా మనం ఈ రకరకాల
సార్ మనకి దాదాపు సమయం అయిపోయింది. సో మీరు ఒక్కసారి దాన్ని వైండప్ చేసేస్తే సరిపోతుంది. So thank you, sir. Thank you for accepting our invitation and you came to our studio and explained about the motion of the rigid bodies. Thank you very much.
నమస్కారం.